Ayan guys, good morning po. Welcome to my YouTube channel, Teacher Dex Channel TV. Today, I'm going to present to you another gas law. So we are done with Boyle's law, Charles law, and we have the Gay-Lussac's law. So this time, I'll be discussing with you the combination of the three gas laws, which is known as the combined gas law. When we say combined gas law, it is known as the pressure volume temperature relationship or volume pressure temperature relationship. So there's no such constant. Okay? Lahat po kasama na po the three measurable properties of a gas. These are the volume, pressure, and temperature. So, ayan guys, we're talking about now the combined gas law. Okay? The three properties of gas usually change at once under experimental condition. Okay? The four possible variations are as follows. Both temperature and pressure cause an increase in volume. Second, both temperature and pressure cause a decrease in volume. So temperature and pressure may cause an increase and decrease in volume. The third, temperature causes an increase in volume and pressure, which causes a decrease in volume. Temperature also causes the decrease in volume and pressure, which also causes an increase in volume. So these are the possible variations of the combined gas law. The three gas laws discussed earlier can be combined and may be expressed into one equation. Okay? So we will try to see combined gas law, or known as the general gas law. It allows you to directly solve for the changes in pressure, volume, or the absolute temperature. So here in the gas law, we will be using the absolute temperature, wherein the Celsius must always be converted into a Kelvin, which is you have to add 273.15 Kelvin. Scientists generally follow the reference point for gases, which is 0 degrees Celsius and 1 atmosphere pressure by standard or international agreement. This reference point refers to the STP, or the standard temperature and pressure. Standard temperature is 0 degrees Celsius, wherein 0 degrees Celsius is equal to 273.15 Kelvin. Standard pressure, it could be 1 atmosphere. Okay? So, standard temperature, which is known as STP. Generally, we can express this equation using this. Okay? The equation can be expressed as follows. We said, Boyle's law, in Boyle's law, we have volume is inversely proportional to the pressure. Where in Charles' law, volume is directly proportional to temperature. Always remember, in Boyle's law, the constant is temperature. In Boyle's law, the constant is pressure. And in the Gay-Lussac's law, the constants are the number of mole and volume. So to combine these two, combined gas law, wherein volume is inversely proportional to the pressure, or PV is proportional to temperature, or PV is constant. Okay? So we have to compute this in constant, wherein mole is constant. This can be derived from P1 V1 over T1 is equal to P2 V2 is equal to, or there is what we call P1 V1 over T1 is equal to P2 V2 over T2. Let us try to derive this equation on how we're going to solve the problem. Okay, so let us try to see a given example. Okay, a given mass of gas has a volume of 893 milliliter at negative 33 degrees Celsius and 480 torr. Calculate the volume of the gas at 30 degrees Celsius and 210 torr of pressure, and the amount of gas is constant. Okay? So anong hahanapin natin dito in this problem? We are going to calculate the volume. We are going to calculate the volume. Let us try to see the given. We have V1, which is 893 milliliter. Okay? So hinahanap natin is V2. There is V1. There is no V2. T1 is negative 33 degrees Celsius. P1 is 480 degrees Celsius. There is also T2, which is 30 degrees Celsius. And we have P2, which is 210 torr. So that is the problem that we're going to solve. So ayan. So we will try to identify the given in the problem. So first, we have V1, which is 893 milliliter, followed by T1, which is negative 33 degrees Celsius. So plus 273.15, because as what I told you, we must always express in absolute temperature. So this is 240.15 Kelvin. It is already in absolute temperature. So this time, we have our P1, which is 480 torr. Next is we have T2, which is 30 degrees Celsius, plus 273.15. So this is 303.15 absolute temperature. Okay? Next, we have P2, which is 210 torr. So, what is the unknown? V2 is unknown. So, ito po yung given. So, what are you going to do now? We have to derive our equation. Let us try to see. P1 V1 over T1, which is equal to P2 V2 over T2. Cross multiply. So we have here P1 V1 T2 is equal to P2 V2 over T1. Multiplied by T1. So hinahanap natin is V2. So divide both sides kung ano yung katabi niya. So P2 T1. So P2 T1. So cancel this. So our equation, our formula in solving V2 will be V2 is equal to, okay, P1 V1 T2 over, we have P2 T1. So this will be our formula. So what are you going to do? Substitute now. We will substitute. So we have P1 is equal to 480 torr. Okay, multiplied by the V1. V1 is 893 milliliter. Multiplied by our T2, which is 303.15 Kelvin. Okay, divide by. So we have P2, which is 210 torr. Multiplied by the T1, which is 240.15 Kelvin. So what are you going to do? Cancel the Kelvin, cancel the torr. Okay? So we will use calculator. Medyo may kalakihan po ang number na to. So 480 multiplied by 893 multiplied by 303.15. So we have here 942 point million pala. 216. Okay. 216 over, okay? 210 multiplied by 240.15. So we have 50,431.5. So i-divide po natin yung dalawa. So 129,942,216 divide by 50,431.5. So our answer is 2,576.61 milliliter. So this is your final answer. If you're talking about combined gas law, we are dealing with a bigger number. Okay? Medyo malaki-laki po ang sagot natin. Okay? Because as what I've told you, we are talking about combined gas law. There's no such constant. Okay? There's no constant in this law. So that's for our combined gas law. So natapos ulit natin ang isang gas law ngayong araw. So sa lahat po ng hindi pa po nakapag-subscribe ng ating YouTube channel, do not forget to like, comment down, and subscribe my YouTube channel, Teacher Dex Channel TV. That's all for today. And do not forget to press the notification bell for you to receive the updates of my videos. Thank you very much and God bless everyone.